Hello students, welcome back to my channel. Today we'll start with a new chapter of physics. We'll start with chapter number 9, ray optics and optical instrument. Okay, so first let's start with the basics. Okay, this chapter light, you have already studied in standard 10, right? So let's start with the basic. First, light. What is a light, right? Light is an electromagnetic radiation. Okay, light is nothing but it is an electromagnetic wave or electromagnetic radiation. You can say visible light, that is high frequency electromagnetic wave with a small spectrum, right, which produces sensitivity in our eyes when it reaches to that, right? So what can we say about light? It is a high frequency electromagnetic wave, and what it does, it produces sensitivity in our eyes when it reaches to that. Okay, so that is light. See, whatever we are able to see, it is only because of light. In absence of light, we will not able to visualize anything. Right? So that was about light. We'll go in detail in this chapter. Second, speed of light. Now, what is speed of light? You take any electromagnetic wave, okay, its speed is 3 into 10 raised to 8 meter per second. So speed of light is also 3 into 10 raised to 8 meter per second, or 3 into 10 raised to 5 kilometer per second. Okay, so this is the speed of light. Wavelength. What is the wavelength of light, or it's a wavelength of the visible spectrum? That is 400 nanometer to 700 nanometer, or 4000 angstrom to 7000 angstrom. Okay. Next, ray of light. What is a ray of light? We always know that the light travels in a straight path. So remember, the wavelength of the light wave is very small. Now, what is wavelength? This is a wave. Okay, the distance completed by one wave. Right here, one wave is complete. So this distance, that is called lambda, and that is the wavelength of a wave. Now see, 400 nanometer means 400 into 10 raised to minus 9 meter. So the wavelength is very small. So we are considering that light is traveling in a straight line. Okay, and that straight path in which light travels is called a ray of light, right? When you consider this as a straight path of light, then this is called ray of light. And the bundle of such ray is called beam of light. Okay? So what is this ray of light? The straight path in which light travels. Okay, let me erase this. Is called ray of light. And what is a beam of light? Bundle of such ray. Right, means if you are taking this bundle of such rays, it is traveling, then this is called a beam of light. You might have observed that in a dark room, if there is a small hole through which a light is entering, you will observe a straight beam of light. Okay, so these were the just basic, very basic introductory concept What is light? High frequency electromagnetic wave having a very small spectrum which produces sensitivity in our eyes when it reaches to our eyes. Okay, speed of light 3 to 10 raised to 8 meter per second or 3 into 10 raised to 5 kilometer per second. Wavelength 400 nanometer to 700 nanometer. You can also say 4000 angstrom to 7000 angstrom. Ray of light, the straight path in which light travels is called ray of light, and bundle of such rays of light is called a beam of light. Okay, so just quickly go through this topics. Okay, so now next, let's move to the next topic, reflection. There will be two basic phenomena that you will be learning in this chapter, reflection and refraction. Okay, these two things you will be studying. So let's start with reflection. Now, first, what is reflection of light? Okay, now let's say if there is a medium or okay, this is a plane surface. Or else, let's say this board is a plane surface. Now, when light will incident on this surface, what will happen? It will not pass through this board, right? This board is an opaque object. It will come back in the same medium, right? See, when light is incident to a plane surface, okay, opaque surface, then it comes back in the same medium. This is called, this phenomena is called reflection. Okay, clear? When light is incident on an opaque surface or on a plane surface, a reflecting surface, it comes back into the same medium. This phenomena is called reflection. Okay. Now, two important point: angle of incident, angle of reflection, and normal to the surface. Okay, now see, these are the three concepts: angle of incidence, angle of reflection, and normal to the surface. Now, first, what is normal to the surface? Okay, now this is the point of incidence, right? If I draw a perpendicular to this plane, okay, to this planar surface, when I draw a perpendicular, then that is called the normal to that surface. Okay, it can be anywhere, okay, but it must be perpendicular to the surface. Here I have drawn the normal at the point of incident, okay. Now the angle, this is incident ray and this is reflected ray. Okay, the angle between the incident ray and the normal, that is called angle of incidence. Okay, and the angle between the normal or reflected ray and normal, that is called angle of reflection. Okay, so these are the three basic concepts you have to remember: angle of incident, angle of reflection, and the normal. Remember, this is incident ray, and this is the ray which is coming back in the same medium is angle of is reflected ray. The angle between incident ray and normal is angle of incidence. The angle between reflected ray and normal is the angle of reflection. Okay, clear? Now let's move to the next important topic, law of reflection. Laws of reflection you have already studied in standard 10. Okay, so you just need to revise it. Okay, see, let's take this reflecting surface. Okay, angle, this is incident ray. Okay, what will happen? Reflected ray, it will come back in the same medium. This is reflected ray. Okay, let's draw a normal. Okay, means perpendicular 90 degree to the surface. Okay, this is angle of incident and this is angle of reflection. So what is the first law? I is equal to R. Okay, and the first law states that the angle of incident is equal to the angle of reflection. Okay, this is the first law. Second law, see here you can see the plane of a board. Okay, the angle of incident, angle of reflection, sorry, the incident ray, the reflected ray and the normal are in the same plane. Okay, so the second is incident ray, reflected ray and normal at the point of incidence, all three are in a same plane. Okay, all three are in a same plane. Remember this. Means it cannot be like this that incident ray is in this way, reflected ray is in this way, and normal is in this way. Clear? I cannot draw normal in this way. Right? I cannot draw normal in this way, incident in this, and reflected. All three must be in a same plane. So this is the second point. So remember law of reflection. First is angle of incident is equal to angle of reflection. Second, the incident ray, reflected ray, and normal at the point of incident are all in the same plane. Clear? So just go through this point law of reflection. Okay, now law of reflection is valid for both plane as well as curved surfaces. Okay, law of reflection is valid for both plane as well as curved surfaces. And one more point I would like to add, I have studied angle of incident, angle of reflection. I would like to add angle of deviation. Okay, what is angle of deviation? Okay, see, incident ray was going in this way. If there was no reflecting surface, then it will pass away in a straight line, right? But it has deviated from here to here. So this is angle of deviation delta. So what is angle of deviation? Angle between incident ray and reflected ray. This is angle of deviation. Later, in case of refraction, we will see that the angle of deviation is angle between the incident ray and refracted ray. Okay, that we will study later on. At present, just see that angle of deviation is angle between incident ray and reflected ray. Okay, so now just go through this topic. Okay, now let's start with the types of mirrors. Okay, now we will see various types of mirrors. Okay, three types of mirror you are going to study in this chapter: plane mirror, concave mirror, and convex mirror. Okay, so first I will write it down: plane mirror, and second, spherical mirror. Okay, now plane mirror, the mirror that you are using in your day-to-day life. That is the plane mirror, just for watching your face. Okay, that is the plane mirror. Okay, it's having a plane surface. Okay, this is the back side, that is the colored surface, and this is the front side, that is the reflecting surface. Means if you want to look your face, you will stand in front of this area. Okay, and this is the back side area. Okay, so this is the plane mirror, straight, right? Now spherical mirror. Okay, now what are these spherical mirror? Let's say this is a spherical shell. Okay, it is a spherical shell. Now, this spherical shell, if it is cut in this form, okay, this portion is removed. Now, one of the surface is made reflecting, and let's say the back portion is shaded. Then this type of mirror is called spherical mirror. Okay, you can also do in this way. You can paint it on this side and make this as the reflecting surface. Clear? So these are spherical mirror. The mirror that are made from the spherical shell. Okay? And one of the surface is made reflecting and one is color. So two types of spherical mirrors are there. See here. Which area is the reflecting inner area? If the inner area is made reflecting, then it is called concave mirror. If the outside area is made reflecting, then it is called convex mirror. Okay, even convex mirror also you are using in your day-to-day life, like the mirror that is in your vehicles, right? Two-wheelers, right? You will see that in two-wheelers, convex mirror is used because in convex mirror, the size of image is smaller compared to the original size, right? Just imagine that the whole truck, big size truck, okay, you are viewing in a small mirror only because the size of truck you are observing in the mirror is smaller, right? So that is the reason that in vehicles, convex mirror is used. Okay, and this is the concave mirror in which inner area is reflected. So these are the types of mirror that you are going to study about in this chapter. Okay, if you are saying plane mirror, then the size will be exactly same, right? Okay, if you are 6 feet, if your height is 6 feet, then in plane mirror, your height will be seen to be 6 feet only. Clear? But in convex mirror, it will be less. In concave mirror, okay, it depends your position. Okay, the magnification may be higher, may be lesser. Clear? That we will study in detail in the next sessions. Okay, so just note down this topic, the types of mirror that you are going to study in this chapter. Okay, now let's see some points related to spherical mirror. Some definitions. Okay, so let's see some definition related to spherical mirror. So first is aperture. Now what is aperture? Okay, it is the total reflecting surface. Means if this is a curved mirror and this is the reflecting surface, then this total surface that you are visualizing, that is the aperture. Okay, so what is that aperture? Total reflecting surface of spherical mirror. Okay, the next one is pole. This is pole. Okay, so what is pole? The exactly the geometric center. The geometric center of this spherical mirror is called pole. Okay, clear? Next, center of curvature. Now see here, if I extend this as a sphere, right? Assume that this was the sphere and from this, the spherical mirror was made. Then this would be the center of that sphere, right? So this point is called center of curvature. Okay, this is the center of curvature, the center of the spherical shell from which the spherical mirror was made is called center of curvature. Okay, and this distance from the center, sorry, from the pole to center, this is called radius of curvature. Okay, so we studied two things, center of curvature radius of curvature. Okay, this line, the line joining center of curvature and pole. See, I'm using the word line, so I can extend it also. Okay, so the line joining center of curvature and pole is called principal axis. Okay, so that is the next thing. Fifth, principal axis. Okay, then if I take parallel rays, okay, see if I'm taking this ray is parallel to principal axis. Okay, then what will happen? It will pass through a point. Okay, if I take another parallel point, it will also pass through the same point. That is called focus. Okay, means when a parallel ray to principal axis are incident on a curved mirror, the reflected ray passes through a common point that is called focus. Okay, and this distance is called focal length. Okay, this distance is focal length. The next point is paraxial rays. The rays which are very close and parallel to principal axis are called paraxial rays. Okay, so in most of the cases, we are going to take the examples or we are going to take paraxial rays in numericals and studying various theoretical concepts. We are going to consider the paraxial rays. So, what are paraxial rays? The rays very close and parallel to principal axis. Okay. Now, two types again: converging mirror and diverging mirror. Converging mirror, diverging mirror. Okay. Converging mirror is concave and diverging mirror is convex. So what is the difference? See here, what happened? This is a concave mirror. You have seen that when the rays are passing through this, okay, they are, if I will draw a ray here also, it will pass through this way, right? So the rays are converging. So such type of mirror are called converging. When parallel rays are incident on the curved surface of mirror, they seems or they are passing through the focus. Clear? So they are focusing at a common point called focus. That is called converging mirror. And if I take convex mirror, okay, this is the principal axis. See what will happen when parallel rays are incident. This is the focus. Okay, they are appearing to diverge from the focus. See, they are appearing to diverge from the focus. Sorry. Clear? So that is diverging mirror. In converging mirror, when parallel rays are incident on the surface, they are converged at a common point focus, and when in diverging mirror, they seems to be diverged away from the focus. This is diverging mirror. Okay. So again, let's revise all the points. What is aperture? The total reflecting surface of the spherical mirror is called aperture. Pole, the geometric center. The geometric center of the reflecting surface is called pole. Center of curvature, the center of the spherical shell from which spherical mirror is made is called center of curvature. Okay, radius of curvature, the distance between the pole and center of curvature is called radius of curvature. Principal axis, the line joining the center of curvature and pole is the principal axis. Focus, okay, then what is focus? Then parallel rays are incident on a spherical surface. They are about to pass through a common point called focus. The distance between pole and focus is called focal length. Paraxial rays, the rays parallel and very close to principal axis are called paraxial rays. Converging mirror, when parallel rays are incident, all the reflected rays are converged towards a common point called focus. That is called converging mirror. And in diverging mirror, they appears to be diverged away from the focus. Concave mirror is converging mirror and convex mirror is diverging mirror. Okay, so just go through these topics. Okay, so that's it for that's it for today, right? In our next video, we will continue with this chapter. Thank you.